Welcome to CS420, Programming Languages. This lecture is about aggregate data. And we're going to first talk about our different data models, a direct versus indirect data model, and then we'll talk about call-by-value versus call-by-reference. Now, aggregate data is any sort of data that has more than one value. So this includes arrays, objects, or structs, and any other data that has more than one value. And these concepts will also apply to data that only has one value, depending on the language, because they might treat it the same way as they treat aggregate data. I think this lecture will really help you understand what happens when you pass aggregate data into functions. There's a lot of confusion out there and a lot of questions on Stack Overflow about what happens when I pass an array into a function. And by reviewing this lecture, you'll have a really good idea of how the data is treated inside of your programming language so that you can smoothly navigate and know exactly how to pass your data in so it acts the way that you want it to. Now what I've drawn here are an example of an environment in both the direct and the indirect data models. In this case right here, this is an array, which is one type of aggregate data, and it is stored directly, and this is a singular data type like an integer. And over here, this is an array stored indirectly, and this is an integer stored indirectly. So now let's talk about our data model. When we have a direct data model in our language, that means when we say a variable name, we mean the data that name refers to. So in a direct data model, when we say A, we get the array. And also if we're dealing with singular data types like integers, when we say X, we really mean that the value 5. In an indirect data model, when we say A, that's really a reference that points to our data. And when we say X, say if we have a singular data, then that too is a reference that points to our data. Let's talk about how this applies to these languages right here. Now C and C++ all combined together. In C, if we want memory, we use malloc or calloc, and that memory is stored on the heap. And in C++, we use the new operator to get memory stored on the heap. So in C, if we just declare a variable, this is C and C++, if we just declare a variable or an array or an object or a struct, that will be stored on the heap like this. So if we declare an array and we do not use the new or malloc or calloc, then our array is stored directly. And we usually store that on the stack. Whereas if we use new or malloc, that means we have an indirect data model. The data is usually stored on the heap, and when we say A, we get a reference to the array that we created. Now in Java, most singular data types are stored directly like this, and classes, arrays, and strings are stored indirectly like this, and you usually have to use the new keyword to be able to get a reference to an object. Now, if you do have singular data and you want to store it indirectly, they have created classes like the integer class and the double class that you can create an integer class and store the integer indirectly through a reference. In Swift, they have value data types, which basically means we're going to store the data directly, and then they have reference data types, which means that we're going to store the data indirectly. So structs are value data types, and they store that stuff on the stack directly, versus classes, which are reference data types, and they store that indirectly. Now what we're going to do for the rest of this lecture is see what this code does if we have a direct data model and we're doing call by value, if we have an indirect data model and we're doing call by value, And then we'll also compare it to call by reference, and if we have a direct or an indirect data model. So what this code does is we declare two arrays, one array of length 3 that has 5, 6, and 4 inside of it, and then another array of length 2 that has 3 and 8 in it. Then we'll end up calling this function, passing in the array of length 3 in as a parameter to x. And then we'll change one of the values in the array. We'll change the x array to point to this second array that we've created, or to be the second array that we've created. And then finally, we'll change one of the values in that array. And we'll see how whether we have a direct or an indirect data model affects what happens to the arrays at the end. And we'll also see what happens when we do it with call by reference. So now let's see what happens when we run this code with a call by value using call by value and a direct data model. So since we have a direct data model, we can see that U and V are directly bound to the arrays we created. Now when we call our function P, which is a closure, and we pass in U for the parameter, since we're doing call by value, that means we make a copy of what U is bound to. So what will happen is X will become a copy of this array, and we'll also copy the contents of the array as well. So X gets its own copy. So now we'll run the code. X sub 1 will be equal to 7. So we'll take this 6 out and replace it with 7. Then we will set X equal to V. So we'll look up V and we'll see this. Now we have to decide what does it mean to set one array equal to another array. And in this direct data model, there's different ways they can do it. One, they could just copy the values of the array into there, or they could kind of erase this array from memory and create a new one that's equal to this one. So we'll do that second way right there. We'll erase that array out of memory and we'll create a new array, and that array will contain the same contents that the V array has. And then at the end, we'll set the first element equal to 9, so we'll erase the 8 and replace it with 9. But as you can see, because we did call by value, our original arrays are not changed at all. Now an example of this is Swift. Swift always does call by value. And if we're using a direct data type, which is a value type, or structs, and arrays are structs or a direct value type in Swift, this is something that something similar to what Swift will do when we pass an array into the function. Now the only thing that I'm not exactly sure about is if we assign one array equal to another array, exactly what Swift will do in that case. C and C++ can also do this. If you do not use the new operator in C++ or malloc and calloc in C, that means your data is stored directly, and if you pass an array into a function, you're going to make a copy of the data, and no matter what that function does to the data, it's not going to change your original arrays. Now let's see what this same code does if we're going to do call by reference and we have a direct data model. Now call by reference means when we pass a variable into a function, that the function receives a reference to the original one. So in this case, when we pass U, which is this, for X, the X now becomes a reference to U. So it kind of points to the same area that U points to. So now when we change X and make the first element 7, we change the U array. We once again need to kind of decide what does it mean to set one array equal to another array. And if we do the same thing, that means we erase the original array and we create a new array that has the same data as the original array. We'll do the next line of code right here and set the first element equal to 9. So we can see by doing CallByReference, and the full reason why you want to do CallByReference is because you want your function to be able to change the original values. And you can see that it actually did. It changed u. First it changed one element in the u array. Then it completely erased u and made it equal to some other array. And then it changed another element in that array. So we can see that CallByReference achieved its goal by allowing the method p to manipulate the data externally, or to change the u array that we passed in. An example of this is C and C++. Now C and C++ usually do CallByValue, but if you put an ampersand in your formal declaration of your methods in the formal parameters, you signify that you want that parameter to be passed by reference instead of passed by value. And if you do that with an array that you declared directly, this is what C will do to it. Now let's go to indirect data models. So with indirect data models, we have all of these references, and everything that's aggregate data is stored not directly in the environment, but through a reference. So we have our values here, our arrays here, and we're getting ready to call our function and to pass in this array to the function. What that means, since we're doing CallByValue, is we're going to make a copy of what u points to, meaning we're going to copy the reference. So in this case, we don't copy the array, we just copy the reference to the array. So now x is a reference that points to the same array as u. So now let's run the rest of the code. We're going to set the first value equal to 7. And then we're going to assign x to be equal to v. So what that means is we'll erase what x is equal to, or this reference, and now we'll make the reference point to something else. And then we're going to assign v's first element to 9. So in this case, we see that the u array was able to get changed even though we passed it by value. But we only passed the reference by value, so our method was able to manipulate the data that the reference pointed to. And by changing what the reference pointed to, then we're able to manipulate v as well. So this is what Java does on arrays and objects. And it's actually pretty helpful because you can pass an object into a function. The function can change the data of the object, and when you return, your object has now has new data or a new state inside of it. Now Swift also does this when you have reference types. So with classes, when you pass a class into another function, you pass the class by value, but you're passing a reference to the class, not the actual class. So now let's see what happens when we do CallByReference with an indirect data model. So when CallByReference means that instead of making a copy of what we're passing in, we make a reference to what we're passing in. So in this case, when we're getting ready to call our function and pass u in, we'll set x and we'll make it a reference to what u points to. So x is now a reference that points to the reference of u. And if we go ahead and follow the rest of the code, the next line is we set the first element to 7. And now here's something really interesting that will happen when we do CallByReference when we make this assignment. what we're saying is make the reference point to V. So we'll erase this connection right here, and we'll make the reference now point to V. And if we're doing garbage collection, or say automatic reference counting, what will happen to this? This array will get garbage collected or removed out of memory. Now if we're doing something like C, we have now lost a pointer to this array, and we now have a memory leak. But let's continue executing our code, and we'll go ahead and set x 1. So if we look up x and we follow it, we set the first value equal to 9. And now here comes our surprise when we come back to our language. U and V are pointing to the same array. They're aliases of the same data, and this array has been deleted out of memory if we're doing Swift, languages that either have garbage collection or automatic reference counting. Now Java and Swift do not have call by reference, so you wouldn't have to worry about doing this in Java and Swift. But you do have call by reference in C and C++, and you have a way to have an indirect data model by using pointers. So it is totally possible to do this in C and C++. All you have to do is make sure you use the indirect data model by using the new keyword. And by the way, you can also create pointers that point to data that's stored on the stack. So this doesn't have to be data that's on the heap. It can be on the stack as well. But you can pass the pointers in by reference, which will allow the function to change what the pointers point to. And so that's the goal of call by reference, is to allow the function to change what you're passing into it. So hopefully this lecture will clear up a lot of confusion on what happens when you pass aggregate data into functions. So if you're learning a new language, the two questions you want to ask is, one, does this language do call by value or call by reference? Most likely it's going to be call by value, not call by reference. Now some languages like C and C++ have a mechanism where you can by default do call by value, but if you want to do call by reference, you can do that. And then the other question you want to ask is, my data stored directly or indirectly in the environment? And if you know those two things, then you can figure out how it's going to treat arrays and objects and structs when you pass them into functions.